Hello and welcome to Pytechie. Today's topic is measure of dispersion. We will diving into the range, variance, standard deviation to understand how data spreads and behave. First, we will see what is a range. Range is a basic measure of dispersion in a data set. It tell you the spread of your data. So, for basic formula to calculate the range is by separating largest value from the smallest one, we will get the range. So, if the range is higher, then we can say in our data set we have some kind of outlier. If it is lower value we get range, then we can say we have a tightly clustered kind of data. So here we have a very simple example where we have a data set 10, 15, 30, 20, 50. So highest value is 15 and lowest value is 10. By after separating highest value from the smallest value, we will get the 40, which is a range. Now let's see what is the pros and cons of the range. Pros, it is easy to calculate, and cons, we can say that it is sensitive to outlier. Like I have earlier told you that if we got range value is higher, then we can say that it is there is some kind of outlier we can say. And it is also not considering all the values, it is only considering the first and last, like lowest and highest value. So that's the cons of the range. Now let's see what is a variance. So by using variance, we can measure the average square distance of each value from the mean. It shows how spread out your data is around the average. So higher variance means the data is more spread, while a lower variance means data is more clustered toward the mean. So you can consider as a mean as a center point of the data set. So here we have a simple formula to calculate a variance. From each data point, we will subtract a mean, and then we will take square of that and divide the number of data points. Now let's see a simple example. So you will get the clear idea how to calculate a variance. Suppose we have a data set 4, 8, 5, 3. First, we will calculate the mean or average. If you are not aware about how to calculate a mean, then you can check out our previous video. So after calculating a mean, so here we are getting the mean, which is a 5. Now let's calculate a variance. So first we will subtract 4 minus 5. 4 is a data set and 5 is our mean. And then we'll take the square. Then we'll do the again 8 minus 5, the again second data set, the third data set 5 minus 5, and then fourth data set 3 minus 5. We'll take square root of each, and then how many data points we have here? We have a 4 data point 4853. So we'll divide it by the 4. Now after separating 4 minus 5, we'll get minus 1. And if we do the square of any minus value, we'll get the positive value. So square of the minus 1 is a 1. Square of 3 is 9. 0 is 0. And minus 2 is 4. After that, we'll add all this value and divide by 4. So we'll get 14 divided by 4. And the final variance value is 3.5. So this is how you can calculate a variance. Now let's see what is the pros and cons of the variance. So unlike range, here we are considering every data point. So this is the pros, like variance value, the final variance value we are getting, which is based on the each data point. So it's capture overall data dispersion. Now we can see. Now let's see what is the cons. It is a sensitive to extreme value or outlier. It is also use squared units. That means if your value is 0 to 10 scale, then it will give you the around 100 or something like 50, 60 values. So which is not on a 0 to 10 scale, is a 0 to 100 scale, right? So it that's why that's the cons. You can't interpret it with the directly with your value. Now let's see standard deviations. What is a standard deviation? Standard deviation is the square root of the variance. So it tell you how much data tends to deviate it from the mean in the same unit of as the data. So like I earlier said, variance, we are getting very huge value. So if your data set is around 0 to 10 scale, then variance is so if you calculate the variance, so variance value will get very much higher from the corresponding to your data set. To make variance value to our existing data set range, so we can use the standard deviation, so which take the square root of the variance. So in our variance example, we have calculated the variance, which we have got at 3.5. And after taking the square root of that, so we will get then 1.87. So why standard deviation is useful? It give a real world sense of spreads. Like if your data in kg, then you will get the data your the standard deviation value is also in kg. If you are calculating some kind of dollar value, then also you will get the data in that range format. And it is widely used in a data science, ML, and analytics. So in left hand side, you can see the chart where the center of data set, we can say, it is a mean, which is denoted by the mean. And then we can say how much data spread around the mean. So this is one of the normal distribution kind of data we have. So that's all we all have. We'll see you in next one. Thanks for watching the video.